Hello, friends. Welcome to our channel. Let's have a look at problem 3561, resulting string after adjacent removals. In this video, we're going to use stack, the abstracted structure, to address this problem. So here we need to pay attention to the following notes here. We're going to consider the alphabet as circular. For example, A and Z are consecutive, right? So but you might ask why we should use stack, or from which we can interpret that we could use stack to address this problem. Actually, it's from here. So remove the leftmost pair of adjacent characters in the string, right? So shift the remaining characters to the left to fill the gap. So this first bullet point is the main point that gives us hint to use stack, right? So here, the length can be as long as 10 to the power 5. In other words, we need to consider term complexity. Another one is that S consists only of lowercase English letters. This actually indeed simplifies the problem. And it also should have such constraint or additional assumption due to the definition of consecutivity, right? So with that said, let's do the coding. So here, in order to check if two characters are adjacent to each other, I'm going to uh, um, call this string called ASCII lowercase. Actually, it's nothing but um, uh, alphabet, so you can print out that. So ASCII lowercase. Right, so this is from A to Z. So what I want to do actually is to assign each character a index. So when we do the check to see if the two characters are adjacent, we just need to do some simple algebra, right? So let's do this. So character I, for I character in enumerate ASCII lower case. So this way, we are going to assign character A to be 0, and character B to be 1, and the character Z to be 25, right? So you can print out this also. Right, A is 0 and Z is 25. So in general, if two characters are adjacent, so their value difference is 1. So in the sense of absolute value, right? But if you consider A and Z, so the difference is 25, either positive 25 or negative 25, right? Therefore, we know how to check if two characters are adjacent. So now let's look at the main logic. So I'm going to initialize a stack, and then we're going to linear scan the string. So for character in S, then what we want to check is if not stack, or so they are not adjacent, right? So the stack the top element and minus the the character. So if they are stack, so the difference should be either zero, either 1 or -1, or 25 or -25. So if or not in this four numbers, 1, -1, 25, and -25, then we are going to append the current character. Otherwise, it means the stack is not empty and the two characters are adjacent. So in this case, we don't care. We don't care about the current character, but we do a pop operation. So the effect is corresponding to delete this pair, the current character as top element. So in the string, right? So afterwards, so you can print out the stack status. So actually what we want to return is the string corresponding to the stack. Just need to use the John for the stack. So it passes the three cases. For example, A, B, C. So A, B are adjacent. We should delete this one, but left Z, right? The second example, A, D is not adjacent, but DC is adjacent. So we delete DC. But now, after we delete DC, B and A are adjacent. So we get an empty stack. Therefore, the output is an empty string. So in case 3, so we have Z and A. So these two letters are adjacent. They are going to be deleted. So we have D and we have B. But the difference of indices for these two characters are 2. They're not adjacent. Therefore, the output is this. So let me comment out this line and then submit. Yeah, it parted all the cases. So here, let me give you a quick analysis of time complexity. So this one, so it's a linear scan of the ASCII lowercase letter. So essentially an O26. So you can just regard it as a constant time. So here is a linear scan, right? Then as drawn is also linear. So overall, it will be O of n, where n is the length of the string S. With that said, I guess that's about it for the current problem. Thank you for watching.